Electrochemistry 2 Blueprint. Part 1, no 1 mark question. Part 2, no 3 mark question. So it's very clear that no 1 mark and 3 marks are there in Electrochemistry 2 chapter. Part 3 carries 1 5 mark question and Part 4 carries 1 5 mark questions. As far as Electrochemistry 2 is concerned, it is having 5 mark questions, no 1 marks as well as 3 marks. Under the 5 mark questions, describe Daniel cell. Daniel cell description is one 5 mark question. A simple voltaic or galvanic cell, its example is Daniel cell. Now let's see the construction and working of Daniel cell. Daniel cell has the simple arrangement of 2 beakers. One beaker has zinc sulfate solution and another one has copper sulfate solution. And zinc sulfate solution is called as left compartment and this one is called right. Left and right. On the left side, in the zinc sulfate solution, zinc anode has been immersed. It is positively charged. Then in copper sulfate solution, copper cathode ray, cathode rod has been kept. Now this anode is connected with a galvanometer, which indicates whether current flows or not. Then it is connected with copper like this. It is called external circuit. Here this is called salt bridge. Salt bridge. Middle one is the salt bridge and this is the anode and that one is cathode. So on the left hand side anode is there, on the right hand side cathode is there. Now let's see what's happened on the left side. The zinc anode kept in zinc sulfate solution. The zinc loses 2 electrons and become zinc ion and 2 electrons. The 2 electron starts to travel in this direction. The electron starts to travel in this direction. And zinc sulfate has been, zinc ion has been left here. Once again I am telling, as the beginning of this, zinc loses 2 electrons. You know very well that loss of electron is called oxidation. So oxidation takes place in anode. So any electrode at which oxidation takes place is called anode. It is on left hand side. So zinc loses 2 electrons and forms zinc ion. This is the first one. On the opposite side, the copper ion present in the solution. The copper ion solution is waiting there. The electron which has been lost runs down. The 2 electron lost by zinc here travels in this direction and reaches here. And it combines with copper 2+ to form Cu. This is the copper ion formed in copper sulfate solution. It gains 2 electrons given by zinc on the opposite side to form Cu, copper atom. So gain of electron is called reduction. At the anode, oxidation occurs. At the cathode, reduction occurs. The salt bridge, the zinc sulfate is traveling in this direction. The zinc ion travels in this direction. Sulfate ion is traveling in this direction. These two are combining in the salt bridge to form zinc sulfate. This is the basic operation of Daniel cell. During this process, when electron transfers in outer circuit and the zinc ion and the sulfate ion travels in salt bridge, comprises a current in this. Current start to flow through Daniel cell. So each electrode has one EMF. Right electrode has one EMF as well as left electrode has one EMF. So another one, a cell terminology has been given in your textbook. It is a 5-mark question. Under the cell terminology, they are telling about current. Current is nothing but flow of electron through any conductor. Electrode, it is a metal. It is a metal or strip of any of the metal rod through which the current passes. Anode, as I have told you, where the oxidation occurs. This is anode. And cathode, where the reduction occurs. Gain of electron. Electrolyte, any salt which can be broken by current, by passing current, is called electrolyte. Light means substance which can be splitted. Electrolyte means a substance which can be splitted by the passage of current. It is called electrolyte. Then I have told you that there is a beaker containing zinc sulfate is called anode compartment. Beaker having copper sulfate is called right compartment. Now let's see the another important 5-mark question called as IUPAC convention. IUPAC convention. How to represent a cell? As I have told you, there are anode half cell and cathode half cell. It is called half cell. The anode half cell has zinc rod and it deals with zinc ion. Then in the case of cathode, copper ion and copper. So while writing anode half cell, it is called anode half cell. It is called cathode half cell. In anode half cell, first we have to write the zinc metal and one separation. This separation is used to represent phase boundary. So this separation indicates phase boundary. This phase boundary separates solution and the metal. So while writing anode, first we are writing metal and the space boundary and the ion. In the case of cathode half cell, first you are writing the ion and phase boundary and the metal. Understood the first convention? It is called the first convention. I have told you that between the anode half cell and cathode half cell, a salt bridge is there. The salt bridge has been represented by a double line. So the double line indicates salt bridge. Single line indicates phase boundary. Double line indicates salt bridge. So this is the representation of a cell. Suppose you want to find the anode half cell potential alone and the cathode half cell potential. It is called left. It is called left compartment and it is called right compartment. The total EMF of the cell, suppose the knot on the top indicates that it is the standard EMF. The standard EMF of the cell is standard EMF of right minus standard EMF of left. So the value of right minus the value of left EMF will give you EMF of the cell, the total EMF of the cell. So this is the way the EMF has been measured for a cell. Now suppose you want to find the right alone. The left has to be made it as inert. Suppose you are making left electrode as the inert, obviously its value is 0. So you can calculate this one. So, in the absence of any one of the half cell, you can't measure the EMF. The EMF of the cell is the collective value for left as well as right electron. So, suppose, as I have told you, one anode has to be found. Anode EMF has to be found. In order to find the anode EMF, for example, you are having Mg and Mg2+. Of course, it forms anode half cell. Suppose you are going to find the EMF of this anode half cell. What they are doing is, the cathode half cell has been made it as hydrogen electron. It is called standard hydrogen electron. The pure hydrogen is kept inside one very small tube having the platinum. The platinum is called inert electron. So the standard